As already told, my name is Giancarlo De Marco, and today I will present my work, which is gamification in construction, and I'll be talking about principles, methods, and applications to construction simulation. The idea started to actually address a specific topic for the gamification, and in this case, we referred to the training as a use of gamification. We decided to refer to the training because simply is considered to be very boring and ineffective in terms of information assimilation. Just consider that any employer would rather prefer to have the employee on site working rather than sitting and to maybe, let's say, supposedly waste its time. Then we decided to cut the specific application on a new relevant figure that the legislative decree 81 from 2008 in Italy has just outlined. Few words will be spent as an introduction, trying to understand what is gamification and what are its applications, about a methodology that can be applied to our scope and how it can interoperate with the existing softwares or the existing platforms. A case study will be outlined and the definition of the next steps will be also presented. So first things first, what is gamification and what are its applications? I think that a parallelism can be drawn between a physical and a digital world. Everybody knows very well the bricks, the Lego bricks with which we play. So what are the characteristics? They're single parts, different shapes, different colors, different, let's say, characteristics. And to have a proper use, they need to be paired to deliver an existing something, a physical toy. In the case here, we can see a Millennium Falcon, which actually is made of single pieces. The analogy on the digital world, on the other hand, we can take as an example, visual programming language. They come in nodes as well as bricks, and they need to be paired to actually deliver something complete. One of the applications can be the micro game, which in this case is one of the applications that Unity itself has designed to help learners to get used to their platform. Let's try just to assemble this concept again. We have the whole and the parts, and tangible and intangible, hence the physical and the digital. We can see that they actually move from parts from tangible parts to intangible whole as the micro game. How this relates to the topic? Well, a playful design can be made out of the bricks, means that you can actually assemble and even make a mock-up, let's say, of your building. You can even use the Lego, would be very fun. On the other hand, the gamification is actually the use of gaming elements to deliver something which is not strictly a game. In our case, we decided to focus on a serious game, which in this case is not, of course, the Unity micro game. So quick facts about the game engines. Who uses them? Well, usually they are operated by programmers or maybe some digital savvies like BIM professionals. They are used leveraging the real-time graphic application of the game engines. And they started to be known at the beginning of the 90s, and well, they're used to actually entertain and the entertainment industry, of course, and the serious game. But let's spend some more words about the gamification. Gamification, so we said, is the use of game design elements and game principle in situation outside the game context. Okay, so the goal is to maximize teaching and engagement by capturing learners' interest and inspiring them maybe to continue learning. Gaming uses natural psychological needs in human, like competitive instinct, desire to succeed, the hype of status, the ability of maybe altruistic cooperation. So using the gamification technique, it can help increase participation in the training sessions, increase the excitement and motivate problem solving, as well as empower and enhance learning. Some of the most common methods can be like a progress indicator, such as points and score, linking tasks with storytelling, and have different levels with progressively increasing difficulty. Why? Well, since players voluntarily spend countless hours on gaming and problem solving, it has been explored ways to leverage video games' power of motivation. So just to draw an analogy between those two stacks here, we have the training path, which defines a goal, and on the psychological side, it represents a challenge for the learner. So also the learning itself is granted through the user engagement, and the skills, well, they're developed because of the competition that can be that can be established between participants to the training session. And so, of course, each achievement shall be rewarded accordingly. How to develop actually a serious game, an application like of this type, a game engine, as we said, is the perfect tool. According to the study research, a good game engine can be considered Unity. Why? Because the presence on GitHub is very extensive. So we can actually rely on this platform to address our problem, and without reinventing the wheel, simply taking the solution for the problem arose from other people. Well, the applications of the game engine, especially from Unity, they are in the AAC sector, in the digital twin and in the games. Why we can say that? Of course, they develop custom solutions for the architecture, engineering, construction sector, and of course, through the real-time visualization and the physical properties that this game engine embeds, it can nicely represent even a digital twin. Of course, a game is the main user of a game engine, so in this case, Unity, and is considered to be a reliable tool also because of that. Which methodology can be applied to our work? Well, an extensive literature has been conducted, and I would say that this Marsh Hours workflow actually fits very well. It defines 7 phases. Now here we just see only 3. The following 4 will be in the next slide. And starting from the beginning, of course, there's the project preparation. In this case, we define which were the goals by listing, ranking, and justifying the objectives we want, and then evaluating whether they were applicable or not. And then moving on to identify the requirements, both for the user and for the context. In the case of the user, of course, the target has to be defined, and to be defined a target needs and motivation have also to be identified and outlined. Just to move on the BIM side, we can say that in the first in the 4th group, actually, in the first of this slide, is where the modeling part happens. In this phase, we have to model the environment, model the information that we want to actually implement. And how to implement? Well, mostly we can refer to 2 aspects, let's say, and each of these aspects can have 2 different applications. Whether we are a company or maybe a design firm that has the ability to implement the gamification approach internally, then we can also decide to have a custom-made solution or a platform-based solution, a software solution. Means that we use something that already exists and we try to adapt our needs to what actually the market at the current stage has. Analogously, in the case we are a small company, we are a small reality, and we want still to implement the design, then we can refer to some external providers for this service. At the same time, those providers can or develop a custom solution or to answer to our needs with a platform-based solution. How to actually acquire data? Well, of course, to acquire data, we can model. and we know plenty of authoring software that can achieve this result, as well as we can maybe have some laser scanner, and this topic relates actually to the digital twin. And the laser scanner can also be maybe implemented with drones and cameras, and also 360 degrees cameras. Some elaboration of the data could be made. In the case of the last three, of course, point clouds or panoramas have to be made, and in some case adapted to generate from the point cloud a mesh model. And in the case of the 3D modeling, maybe going through some more specific software to refine the material would surely deliver a better solution, a better result. So how do we do then? Once we have the model, we can actually import our model to the game engine and to, in this case, Unity. How to do that? Well, there are two ways actually. Of course, the first one is to use an FBX file format, but this Filmbox file format actually provides only geometrical information, and this case does not apply, of course, to us. What can we do? We can maybe try to import an IFC. What's the problem of importing an IFC? That actually Unity is not a BIM software, means that it's not certified from Building Smart, and there is no actually there is not anything there. It's not part of the software, the import of an IFC file. So how do we do that? There are plugins like 3dfi or IFC importer or PIXYZ that actually, even if they bring into the game engine the information and the geometry, yet they're not certified from Building Smart. So the accuracy and the detail of the information transfer is not granted by Building Smart. So just moving on, we can say that instead of having this sort of open approach relying on IFC, we can maybe use a closed BIM approach, as there are platforms already existing that can import and can use and already can implement some solutions that are similar to the one presented in a game engine. After having modeled a construction site information model, we created an extensive object library dedicated purely and solely to this topic, to this scope. Thanks also to this already existing platform, simulation of 4D could have been run. And of course, as part of the integration and the engagement of the user, the immersive virtual relation experience can also be brought on screen. Just to see that in this case, some features are already embedded in the platform, but some others are still to be. In this case, we can see an application of the collision. Of course, this is not something that has to happen. Two bodies cannot intersect, but still we can recognize that there is gravity, and the software already embeds this solution. Why? Because he moved from a higher level, a slightly higher level, and was able actually to move on this slope. But again, the same vehicle on the same slope, but moving backward from a lower level to a higher level would have some problems according to the degree of the slope. So some solutions are already there out. So we have vehicles on vehicle versus vehicles, and they actually collide, such as vehicles versus fences and people versus walls. But something that does not yet happen, as we see, that vehicles versus people, well, they do not collide. They actually intersect, and this doesn't make sense. So this would affect the realistic effect that we want to deliver to our trainee. Also, on this very platform, well, there is some limitation in the equipment mobility. As we can see, the people that should play the NPC characters, well, they cannot perform many tasks. As well as the dynamic objects already designed, there are not too many. and we cannot rely on a very huge library of already existing ones. More objects shall be designed and shall be implemented in this platform. As well as the parameterization means that to actually deliver a consistent construction site information model, specific information shall be implemented in the software itself, and we should be able to edit these properties in the dynamic objects to be. So the case study. Just moving quite fast, I think my time is running out. The appointed work supervisor is the professional that we decide to address to. This person is actually a professional that has to overview all the activities on the construction site, and his objective is to create, of course, a safe construction environment that is required from an industry to go above and beyond the minimum safety rules, which are here listed. So how did we actually do? From an existing construction site, we reproduced the model, and with the information that can be related to a use of ergotechnic of the construction site management. And how we define the levels, or how did we define the logic behind this gaming approach? Well, we of course had to define which is the design and the game. The design is the design of the game. That's why every event has an underlying description, and this very event produces a criticality which shall induce the learner to actually have some sort of action and to undertake any action. This action then has to be validated, or can be evaluated better against the learning objective. Then the definition of levels, of course, has been done. In some cases, like in the event 2, there is no request action because some activities can be related to a subsequent event. So just to make an example, a theme is on the highest level of the scaffolding that we can see in the lower picture on the left, and it's preparing the formwork, just walking around. So the workers, the event presenting is the same. Of course, in this presentation, the design and the event, they are the same because the description is a natural express of the content of the event, while the game stack will actually be helpful for the designer to develop the content of the game. So the criticality, of course, here is the high fault risk or maybe interferences between the operations. And of course, the requested action is from the appointed work supervisor to promptly intervene on the situation. How the game would actually...
In 1 minute.
Yes, okay, thank you. Actually, this would be the workflow of the game from the start, the first event, the criticality, and the requested action. And according to the result, that the action that the appointed work supervisor is will be doing, then we would have points or neglecting points. Some visualization of what could be this application and the abilities that the appointed work supervisor can do on site is, of course, to inspect, to warn about some risks on site, also to talk to the NPC, trying to ask them to wearing a helmet, or more in this case, actually to place a missing tow board. And then also the appointed work supervisor could then call the base camp for bringing wood planks, or if the situation maybe is too dangerous, to call the site manager or the director of works. As well as nobody remembers anything by heart for sure, so also a tool for checking on the safety management plan or the assembly and disassembly procedure for the scaffolding can be checked at all time. So just to conclude, the strength of the gamification in this case has been seen as an highly effective and engaging, as well as safe training. Any action taken in this place, of course, is not dangerous. Some opportunities, well, it can reduce the cost, and of course, it can be an endless reproducibility. The weakness, of course, this is a large, I mean, this is a niche of technology, and its application might be seen as suspiciously and not yet effective. So what are the next steps? Well, the idea is to actually help landing the gamification in the construction market. The application deployment, we can say that it is conceivable, given the current level of knowledge, to construct an application that satisfies the requirement underlying this work, as well as there are tools that can be made interoperable and so produce a result. Just to bear in mind that what has been presented today is an educational construction site information model, while what we foresee is actually a model, a mock-up COSIM, where an existing construction site and an existing information model related to the construction site can actually be used as a real-time application for the training of the workers. So thank you for the questions. Any questions are welcome.